Okay, I think it's now recording. All right. So good morning, everyone, and welcome to the AI and Big Data in Finance Research Forum Symposium series. Today's symposium is titled Recovering Economic Agents' Expectations with AI. We have three excellent papers that study the expectations of different economic agents using AI. So joining us today, we have Suproteem Sarkar from University of Chicago, Marius Guenzel from the University of Pennsylvania, and Manish from Georgia State University, along with our distinguished panelist, Tony Cookson, currently at the University of Colorado Boulder and transitioning to Penn State. Tony is also actively working in this area of research. So the format of today's symposium is as follows. Each presenter will have 20 minutes, followed by Tony's reflections on this line of research and its possible future directions. We will have time for questions at the end of the symposium, but you're also welcome to post questions in the chat, and we will save them and share them with the speakers at the end. So I think without further ado, let me introduce the first paper, Economic Representations. The presenter is Suproteem Sarkar. Suproteem, you have 20 minutes. The floor is yours.
Thank you, Pietro. It's a pleasure to be here. This paper is called Economic Representations, and the motivation is there's a lot of variation in stock valuations, both in the aggregate and the cross-section, with these extensive economic effects. And it's been challenging to explain all this variation, right? We know it's hard to forecast changes in valuations, but also, even with the benefit of hindsight, it's been challenging to explain the historical variation in stock valuations. Now, the point of this paper is that these valuations will depend on how the market characterizes, or what I'll call represents firms. Actually, how the market is reasoning about the economic meat of a firm may influence how the market values it. And there's many ways to represent a firm, right? You might think that Tesla is an electric car innovator. You might think actually it's not a car company, it's an Internet of Cars company. Or you might think it talks a big game, but at the end of the day, it's just an automaker, right? These are not my words. They're words from the press. And each of them conveys a different way of reasoning about, or what I'll call representing, this firm's business. So the core conceptual object in this paper is the market's representation, which can be multidimensional, right? Tesla's a bit like a car, battery, and tech company. It can be time varying, and absent some fast-moving fundamental story, can deviate from fundamentals, right? These three views don't seem to be mutually consistent. So the point of this paper is first going to develop a measure to proxy for the market's representation, and then to use this measure to study some of what drives valuations. So on the measurement side, I'm going to compute these embeddings of firms from financial news language. And on the empirical side, I'll then use this measure to study some of the economic mechanisms that drive stock valuations. So here I'm going to give you one just slide of formalism to fix ideas. I'm going to assume the price of stock S at time t depends on its representation in red and a valuation function vector in violet. So the representation I'll think about as a vector of features, right? How car, tech, battery, and so on is Tesla. And the valuation function is how the market's going to value a bag of features. If we write the price using this form, we can write the change in price using this expression, where two components pop out. The first component is what I'm going to call the valuation function change, right? If you're a car company and there are, shocks to auto demand, that may change your valuation because you're just exposed to different economic forces, right? Things have changed in the economy. You can think about this as, for example, compensation for a bag of characteristics. However, another component also pops out, which is that component on the right that I call the representation change, right? As you change how you characterize a company from more of a car company to more of a tech company, that too can change its valuations because you're moving around how you're reasoning about that company. You're moving around what characteristics you think matter for its business. So in this paper, the first step is going to develop a vector representation of firms where you want to capture some of that, economic perception that the market may have of the firm. And I do so by proxying by the market's perception using financial news language. So I'm going to learn these firm by year embeddings. And to do this, I'm going to develop a new series of foundation models to avoid look-ahead bias and other biases in this setting, which we'll talk about later, and then show how we can use contrastive learning to actually target the embedding space to the language of the financial domain. I'll show that these representations are informative of the market's perceived business models. And then finally, I'll then release these new foundation models to the research community so folks can also apply them to their own work. So at the end of the day, I'm going to have a vector for each firm in each year. Now, how am I going to use that vector? I'm going to use it to try and understand what's moving around valuations. So the first set of empirical results is going to be an ex post variance decomposition of returns, Well, I'll show that both changes in valuation functions and changes in the representations themselves help to explain returns. So I'll show that this decomposition accounts for about 20% of the cross-sectional variation in annual returns, of which two-thirds can be attributed to how the market values a representation changing. Think about shocks to auto demand moving around the stock prices of automakers. And a further one-third can be attributed to the change in representation itself. As you change how you characterize a company, that too may move around its valuation. So there's going to be a lot of that volatility in the representation. I'm then going to understand, what's driving that volatility. Is it justified? And I'll show that some of this variation in the representations of firms can generate mispricing. And so I'll show you that representations that deviate from historical benchmarks tend to revert, and we can bet against this reversion and essentially do a strategy that says that if a firm is talked about very differently from how it's been talked about in the past, that might not be sort of the long run way that firm operates. And I'll look at some mechanisms like high attention, communication by managers, and episodes of new technologies to try and understand what may drive this mispricing, this channel of misperception or misrepresentation. So that's where we're going to go. Given how much time I have, let me give you a lot of the intuition of the paper using just one example. So here are those two headlines I showed you before. What I'm going to do is not take the headline, but the full article, not just one article, but all the articles for a firm in a year, and put it into an embedding space. A high-dimensional vector will be learned for each firm in each year, and I can project that vector in many ways. Here, for this example, I'll just project it on the difference between the average vector for software firms and the average vector for car firms. So what we see here is that during Tesla's IPO, right, it's represented, somewhat like a software firm, but also somewhat like a car firm. Now, we can roll forward the clock to the time that second headline was published, and we see that Tesla's representation moves closer to the representations of software companies, right? People are talking about it differently, and that's being reflected in this geometric representation of the language used to describe that firm. Now I'm going to do is, take the variation in that blue line and use it to understand some of the variation in the valuation. So the first thing we can do for this example is to look at, that first period, right? Tesla's about a third of the way between software companies and car companies, car companies and software companies. So you might think about looking at the future, realized change in valuation of those two sectors, take some weighted average, and use that to impute how Tesla's valuation ought to have changed. And we can do that not just in these two dimensions, we can do it across the entire vector space in a way that kind of avoids overfitting based off just more parameters. And we can use that to impute some change in the valuation of Tesla over the next period. No reason to stop there. We can use the next period's representation and so on and trace out some path of what we would impute the valuation ought to have changed given how Tesla's represented and how the valuations of similar companies had changed. Now that's going to be that valuation function change component. This is going to be the realized return of the firm over that period. And we see we're explaining some of that variation, right? There's some correlation there, but we're not explaining all of the variation. But also on the left, I haven't used all the information, right? I'm using those levels, but I haven't yet used those changes, right? Tesla may be changing in how the market characterizes it. That too may help us to understand how its valuation is moving around. So what I'll do is show that both this example and more generally, if we account for that change in representation, we can get even better explanatory power over the change in the company's, overall valuation. And I'll show that, the valuation function change, we might have some better measurement or different types of characteristics that can augment existing models, but the representation change is something that the language can really help us do, where slower, moving proxies for how the market characterizes firms like industry codes just don't generate enough variation. So that's going to be the first set of empirical results, right? How can we explain changes in valuation? It's both changes in how a representation vector is valued and the change attributable to the change in representation itself. The second set of empirical results is then going to ask, what happens as a result of this volatility in representation? And I'm going to find evidence of reversion, right? We're going to see, movements back to old ways of representing a company, not just for this example, but more generally across the sample. And we'll see that this forecastable reversion in the representation is commensurate with forecastable returns, right? We can actually bet against firms that deviate in ways that suggest they might be valued more highly, or bet on firms that deviate in ways that suggest that they may be undervalued, right? So how can we, put some more, interpretation behind this deviation? So I'll look at a couple mechanisms in the paper. One is this idea of attention, right? If there's high attention to certain features like software, AI, and green, right, that have outsized influence on the representation, this may move the representation away from the firm's operations. I'll also look at the role of communication by managers who may supply different ways of thinking about the firm. And finally, I'll show that when there are new technologies, we often have these ingredients. There's high attention to these technologies. There's also what you might call ease of categorization. It's a very immature type of feature. We might not be, as discerning in assigning new categories to existing firms. And this may help us to understand kind of what may lead a firm's representation to go astray. So to talk a little bit about this paper's contribution, right, there's this work on characteristics-based empirical models where the paper develops these linguistic methods and shows how contrastive learning can target this economic language. There's this work on vector representations of firms, including recent work on embeddings, where here we're going to focus on news language, and we're going to show that this change in representation channel appears to matter beyond kind of static representation for understanding volatility and valuations. There's this broader literature on variation in asset valuations. Right here, we're going to have this firm level measure. And then finally, we have a lot of theory in behavioral economics on things like miscategorization or misplaced analogy. But it's been hard to systematically study some of these predictions in the field. Now that we have this kind of rich characterization of firms, that we hope proxies for how the market may characterize them, we can maybe test some of these ideas in the field. So here is how the overall paper looks. And let me talk a little bit more now about the measurement, right? How do we actually get a vector for each firm in each year, right? So the goal is to learn that vector for each firm in each year, but there are a few challenges. The first is that language models have look-ahead bias from pre-training, right? The knowledge cutoff of language models is often very close to today, but when we backtest trading strategies, we're looking at periods in the past where the pre-training data of the language model may induce information that lead forecasts to go astray or not, reflect the available information at the time. So Paul Glasserman and Kate Lynn have this nice paper. Kian Vafa and I have also worked in this space. It can be an issue with these pre-trained off-the-shelf models. Second, analysis with regularly updated LLMs may not replicate. So Ling Zhao has this nice paper showing how changes in GPT vintages generate different types of results, right? How can we reproduce results when, the frontier labs deprecate their models and we can't go back and revisit the same strategy? Finally, LLMs are not targeted to economic language, right? Melissa has this nice paper looking at in the political economy domain. In the financial domain, you might think that phrases like sharing, two-sided, and platform mean more similar things in economic English than they do in general English. To address the first two issues, I'll develop this new series of foundation models. And to address that that third challenge, I'll show we can actually develop a representation algorithm that's targeted to financial language. So let me just give you a brief idea of how this works. So on the foundation model size, how can we ensure that we know the knowledge cutoff of the language model? Let's use text where we have timestamps. So for this series of foundation models, I'm going to use historical news. And you can think about these models as a family of LLMs with time subscripts that's only going to have a knowledge cutoff that we know goes up to a particular point in time. And this helps the look-ahead bias issue because you can pick the vintage of the model that happens before your backtesting date. And helps with reproducibility because it's an open weights model. You can pull it as many times as you want, and you're going to get the same distribution of results. I've released this publicly. I welcome folks to use it. There's a new version coming out in the coming weeks, and I'd love your feedback on. So now we have this kind of historical language model. There's more in the paper on how we can make that a sequence sort of embedding model. And then the idea is, how do we then target that model to put firms into vectors? So here we're going to build on the work on the embedding transformation in machine learning. So the canonical example is that here are 4 words, right? To a computer, they're just 64-bit strings. But to you and I, we might draw some structure to organize these words. You might think, oh, there are these features like female to male or common to royal that can help us to organize how we characterize these words in our heads. And there's work showing how embedding models can be trained to recover similar geometric structure if we think semantics has some type of related structure. Right? Another example, right here, sushi, here's Japan, here's Germany, Llama 2 embedding space in the top right, you're going to get the word bratwurst as the most similar to that point. So the idea is, can we do something similar to try and back out how the market may map firms in their heads? And right, again, to a computer, the identifier is not going to have much structure, but you and I might organize these four firms like this. We might think that there are more platform economy type firms on the top versus vertical, more food involved firms on the left versus lodging on the right. And just one more example, right? Here's Tesla, here's Ford, here's Planet Fitness, here's my embedding space in 2021. We might want to think about how to fill in the blank on the top right. It turns out in this year, the closest embedding to the top right is Peloton, right? So there's this geometric structure that seems to perhaps help us to understand the semantic structure in the market's heads as it organizes firms. So in the paper, we're going to show that we can, develop an algorithm to kind of build these and include some economic information that might help to organize the geometry. So I'm going to turn to this data set of 4 decades of news language commonly used in this asset pricing space, the Dow Jones Newswires, and essentially apply contrastive learning to it. The goal is to learn an embedding algorithm that maps word sequences to vectors. And the objective here is to treat each firm as a semantic unit. You want to assign higher relative similarity to language from the same firm than language from a random pair of firms. What's the economic intuition here? It's that language about the same firm should, on average, be more economically related than language about a random pair of firms, right? So if you think about all these articles living in this embedding space, and we think about kind of taking some mean of the articles at an intermediate point in training, right? What this will do is it will introduce new training examples where we tell the model that these two articles about Airbnb, you should push them closer together in the embedding space. And then you can kind of iterate this procedure on and on and on, and you reach some geometry. And now we're looking at real data, these four embeddings on the first two PCs in 2021. You're looking at real data where these geometric relationships line up somewhat with those conceptual relationships that we drew in our heads. And there's more paper on the details of how we can develop these algorithms to be targeted to this distribution of language. Now, here's kind of how the rest of the paper goes, right? I'll spend some time validating this measure. I'll show, okay, we can draw similar pictures from before with these geometric relationships. We can do something more systematic where we find that when firms are close together in embedding space, they move together, they covary more, analysts cover them more often. And then the empirical results of the paper kind of take this learned vector and use it to do more formal versions of that example I showed you earlier. Let's take that vector and let's use it to understand how the valuations are moving around. And let's really look at the variation in the vector itself and see whether that can tell us something about how the price changes and whether the firm can be mispriced. Let me just close with one example that helps, I think, to drive the point home for this. Right here, I'm showing you the share of firms in a particular year whose news coverage mentions a particular technology or theme. And I think what we see here is that there are certain types of themes where we see greater cross-sectional interest at some periods in time, but eventually they're not talked about in conjunction with a company as often. Maybe look at internet, which in the late 1990s reached about 80% of firms' news coverage and how often it was mentioned, which then subsided. You look at virtual reality, which we see an increase in how many firms are associated with that characteristic before an eventual decrease, right? This is suggestive evidence that when a firm, incorporates something new, it's not always the case that that new thing is going to be a part of the zeitgeist when interpreting that firm or perhaps a part of that firm's operations in the future. And in the paper, then we take this idea, we do a more, formal exercise where we look at semantic categories as opposed to individual words, and you do find evidence of such reversion, and that such reversion helps us to forecast returns and does so in ways that are associated with this misperception. And if you look at, some hints for what could drive a firm's representation astray, like high news coverage, high attention, communication by managers, or kind of the ease of categorization across these new characteristics, it turns out that these can help us to explain some of this effect. So let me just close there. So what's the motivation here? We want to understand what drives stock valuations. We think that an important characteristic here, a force here, is how the market represents the firms, how it's reasoning about the economic meat of the firm. The challenge here is that this is quite a rich measure, and we might have to turn to new data to get closer to that theoretical object. So what this paper does is it develops an empirical analog, a representation measure to proxy for the market's representation, and uses that to study valuations. The first thing we can do is, develop some of these technical, contributions to avoid look-ahead bias and target the linguistic domain. And then we can kind of take these vectors and show, one, that movements in the representation help us to understand how prices move, And two, that we can take our behavioral economics hat and actually look at that volatility in the representation and try and figure out more of what can move around a company's valuation and when that valuation can go astray. Thanks so much.
Thank you, Suproteem. That was fantastic. I think that in the interest of time, we're going to jump right to the next presentation by Marius. So we're going to switch gear a bit from extracting representations from news. We're going to move to analyst expectations. So the title of our second paper is Mental Models and Financial Forecasts. Marius, as for Suproteem, you have 20 minutes. The floor is yours.
Perfect. And can everyone hear me well? Yep. Awesome.
Yes.
Let me start by saying that I can certainly, as a German, relate to Suproteem's example that bratwurst are very much associated with Germans. And with that out of the way, thank you so much for having me. I'm excited to present this today. Mental Models, Financial Forecasts. This is joined with Francesca at Booth and Paul at ASU. And so the starting point for the paper is kind of like a really fundamental question in finance. How do people form expectations in financial markets? And we typically think that expectations and beliefs sort of reflect underlying information. And while that's certainly true, and that's something that we obviously will come back to in a little bit, we can and need, I think, go a little bit beyond that, because even when we think about two people with the same information set, they oftentimes have very different beliefs. So how people reason about information, how they attend to information is crucial. And that's where we want to make progress on in this paper. And so what we're going to do is we're going to try to measure the interpretable reasoning, which we'll also call mental models, behind quantitative beliefs. We're going to do that in the context of analysts and their stock valuations, because in that context, we have a shot at basically measuring this reasoning quite well and tying it to beliefs of the same forecaster. So let me give you an example. Here's an analyst from Deutsche Bank. As you can see, they report their quantitative beliefs, which in the analyst context are these price target forecasts. So these are 12 months ahead quantitative forecasts at the very top right. But most of these reports are actually text, where the analyst talks about these beliefs, justifies them, explains the reasoning underlying the beliefs. And so the goal in our paper is to combine the textual element and sort of extract the reasoning from that, and then link it to the quantitative forecast and make progress on that link. And when we think about stock valuation, it's a hard problem. We got to pay attention to many different moving pieces, and oftentimes we have to reduce the dimensionality here and decide what to pay attention to and what to neglect. It's also very computationally complex, right? We have to solve this infinite series of cash flow and return forecasts. So we have to simplify the problem and choose different valuation methods in this problem. And so this joint choice of what do you pay attention to, how you, related to Suproteem, how you represent the firm, and how you choose valuation methods to do the valuation, that joint choice is what we're going to sort of call in the paper an analyst mental model. And so the paper starts from a sort of relatively basic conceptual framework, which is at the end of the day sort of a model of top-down and bottom-up attention, sort of to fix ideas. I'm not going to have time to go through that, obviously, in this short talk. But what comes out of this are sort of key empirical predictions based on how analysts would sort of like structure their mental models that we can then take to the data. And in terms of data, we're going to use the near universe of analyst equity reports from Refinitiv since 2000. And then we're going to prompt large language models to extract the reasoning that's stated in these reports. So both the valuation methods used, so is the analyst using a discounted cash flow, DCF method, a multiples-based approach, et cetera. And then we're going to extract from the text these directly interpretable arguments that the analyst makes, 11.8 million of those. So like, what is the topic the analyst talks about? What's the valuation channel? Is it affecting sales or costs or margins? What's the sentiment, positive, neutral, negative, as well as what's the time outlook, forward-looking statement about the past or the present? Before I preview the main results, let me just give you a glimpse into our data. So here's what analysts basically talk about, their reasoning collapsed across firms and across analysts. So just basically just the time dimension. So analysts focus on things like customer demand or products or M&A or costs. And then there's other topics that receive much less attention, like taxation, but there's sort of time variation as taxation matters more. Analysts then sort of like deviates from the steady state. Basically, analysts then pay more attention to that. So this is, like I said, collapsing across many pieces of variation that we have access to, like across forecasters, across firms, and in the empirical analysis, we obviously use the full granularity of the data. And so we're going to have 5 key findings. The first are basically properties of these mental models, right? That's drawing choice of attention and valuation methods. First, very basic level, we show they matter. They predict quantitative forecasts. So basically, what the analyst talks about, what they pay attention to, how they value firms, that shapes their quantitative forecasts. We find that mental models tend to be actually quite sparse and rigid. And what we mean by that is that analysts, on average, talk about relatively few topics, and they tend to have some stickiness or persistence in the topics that they focus on. And I'm going to show you more on that later. And then obviously, or as we might predict, but it's actually hard to show in data, in empirical data, is that different pieces of your mental model, right, this attention and this valuation methods, they're tightly linked. So if I'm, for example, using a DCF method that is more forward-looking than a multiples-based method, I'm going to tailor my attention on what I talk about more towards sort of long-run variables. And so having these two sort of more like descriptive facts about mental model sort of representations or mental model properties, we're then going to bring it to sort of financial market outcomes. The first thing we're going to do is we're going to show that both aspects of your mental model, both attention and valuation models matter for how you sort of change beliefs and expectations about the firm over time, as well as can help explain disagreement between different forecasters forecasting the same firm, the same point in time. Then we sort of go towards biases in forecasts, and specifically over and under reaction. So traditionally in behavioral economics and finance, we've been able to show that forecast revisions tend to overreact or underreact. So forecast revisions predict forecast errors, but we still don't really understand where over and underreaction come from. And where we can make progress here is that we can actually measure over and underreaction at the topic level. So it's 2 different features and variables that analysts pay attention to. So really to sort of understand what ultimately drives over and underreaction. We find that analysts tend to overreact to firm-specific topics, while they tend to underreact to macro-related topics on average. And finally, that over and underreaction patterns, they predict subsequent returns. So overreaction, as we would predict reversals, underreaction to different topics predicts continuation. So that's the paper in a nutshell. Let me now go through some more detail. I'm going to be quick on certain things and highlight sort of the more big picture findings. In terms of the data, like I said, we have the universe or near universe of analyst reports, and we extract the information using LLMs. I'm only going to show you how we extract reasoning, and the valuation method prompt is in the paper. So for reasoning and the attention piece, we're going to ask Claude to analyze the provided equity report to identify all topics that explain the analyst's price target. And we're going to do this by extracting sort of the topic, like customer demand, M&A, what I showed you before, the valuation channel. So is it basically sales or cost, the entity, firm, industry or macro, time outlook, and sentiment. We're going to have a lot of detail in the paper on that. So we use a multi-step prompt to really get sort of like an exhaustive list of arguments and diagnostic tools, basically to show that this output is stable. So if we feed the same reports to the same prompt, we get very, very similar outputs. I'll also say this is not a predictive task for the LLM, but a descriptive task. So we're asking just to give us back what's in the report. We're not asking the LLM to make predictions about the future, etc. Okay, so let me then turn to the first sort of like summarizing set of results, which are these basic mental model properties. And as it'll become clear, is they're going to be shaped, both the valuation methods and the attention, by both bottom-up and top-down factors. But to sort of start super simple, when we look at what are the valuation methods, so the first component of your mental model, what are they on average in the data? We see that 43% of reports use DCF, over 60% use multiples methods in their price target forecast. And of those, or like, P is the most common one, P multiples with 32% of reports using them. And then we see that, as I sort of alluded to, both bottom-up factors and top-down factors shape that choice of DCF versus multiple. In terms of bottom-up factors, sort of like firm characteristics matter. So obviously, DCF methods emphasize more long-run cash flows. Multiples are more sort of emphasizing observable comparables. And so in line with that, we find that relatively speaking, DCF methods are more commonly used for younger and growth firms where these long-run features are sort of more important. And then analysts sort of like tailor their method choice accordingly. One really cool feature that we have is that we see in these analyst reports, not just the lead analyst, but the entire analyst team. And so we can then go back in time basically and ask, well, who trained you when you were not lead analyst yet? And so that's how we kind of like can establish that top-down factors and basically, initial training matters as well. What do I mean by that is how your boss, while you were not lead analyst yet, how they do valuation and what their mental model was basically shapes how you perform valuation years later when you are a lead analyst. So there's this boss effect. And as we would predict from a sort of like a sort of experience-based or sort of exposure-based channel, the more you've interacted with your boss, or the longer you were a trainee, the stronger that effect, and that effect tends to fade as you develop more experience as lead analysts and sort of like move away from that initial training period. So like both bottom-up, top-down factors matter. There's lots more on how valuation methods matter and like cool questions you can ask. So much more that we decided to write another paper on this, where we basically ask which models perform best and why, which is beyond the scope of the mental models paper. That paper is titled Valuation Models. I'm not going to go through like many of the results that we have, but like one thing I would just want to flag, because I think it's super interesting, is we tend to see that these analysts incorporate more and more also sort of uncertainty in their belief sort of derivations in terms of sensitivity analysis, so including bull and bear cases. So basically asking questions around how do they incorporate uncertainty in forecasts, and how does their mental model reflect uncertainty or sort of account for uncertainty, is something that one, I think is super interesting, and two, we're planning on doing more on. And just to explain that figure here, this is basically saying that these bull bear cases have really sort of like increased quite substantially in these reports, with now more than 40% of reports including them. And this is not sort of some macro fluctuation, but it's really sort of a more permanent trend. But going back to mental models and the second piece of your mental model, the attention piece, we again see sort of this evidence that both bottom up and top down factors matter. So going back to these heat maps, as I sort of mentioned at the beginning, there's clearly like some topics that receive like, a lot of attention and focus by analysts across time, like customer demand, product service mix, market expansion, et cetera, et cetera. So relevant topics that are sort of like always sort of represented in analyst discussions. Then there's some topics like tariffs or also inflation that are sort of like more stable, but when they deviate from the steady state, that's when analysts pay more attention to them. And then there's sort of emerging topics such as ESG or also AI and artificial intelligence that, again, from a sort of a bottom-up perspective, receive sort of like varying attention over time. In the paper, we then also established that, again, sort of like top-down factors, again, this mentoring experiences matter as well. And we have some additional evidence on sort of more localized bottom-up factors, such as local inflation experiences affecting how much you attend to inflation. Even for firms located far away, But in the interest of time, I'm just going to sort of refer to the paper for the details on that. But broadly speaking, right, we have this evidence that mental models are shaped both by these top and bottom, top down and bottom up factors, and then we can sort of like move to the key results of the paper. So first key result is that your mental model really shapes your quantitative forecast, so which we translate into expected return forecasts in the paper. So if you pay more attention to sales and you talk about sales in a positive way that sort of predicts a higher expected return, but if you talk about it in a negative way, that predicts a lower expected return. And the same is true for these other valuation channels, for example, cost. So like at a very basic level, this is sort of like almost like a validation for our exercise. And then in terms of the mental model properties, we find that they're sparse and rigid. And so let me go into a little bit more detail what I mean by that. On average, analysts only discuss 16 out of 139 possible topics. And when we look at two analysts forecasting the same firm at the same point in time, there's only a 33% topic overlap. So they're really focusing on a small-ish subset of topics, and they focus on different things. And one way we can then establish sort of sparsity sort of in a little bit more sort of precise way is when we look at forecast errors. So on the left, we look at a forecast and we see that what you talk about explains your forecast, basically that blue bar. But on the right, we look at forecast errors. And so what other analysts in green talk about the same firm and the same at the same point in time, but that what you would omit from your discussions, from your mental model in that sense, that predicts your forecast errors. And that's what we basically call sparsity in the paper. We then have, as a second key property, sort of the finding that mental models are rigid, both across stocks and over time. So basically, I tend to describe firms in a similar way over time, so the same firm over time, and also I'm more similar in my attention to variables and my discussion of firms across firms at the same point in time. There's also some interesting topic differences in rigidity, where topics like monetary policy or GDP tend to be more stickily discussed by analysts over time, and other topics like governance or supply chain, they tend to be sort of less rigid in terms of sort of like that time dimension. And then the second sort of key property in terms of the mental model is that the different components are tightly interlinked, right? That's what I was referring to earlier. DCF emphasized long-term future cash flows. And so the topics I'm going to be discussing if I use a DCF-based method are going to be quite different from the topics that I'm going to be discussing if I use a multiples-based method. And this is what the sort of waterfall chart here tells you, that there's quite a bit of difference in topic attention depending on the method that's being used. All right, so in the last couple minutes, then let me turn to the implications for sort of financial market outcomes. Let me start with valuation changes and disagreement. So we can then ask sort of how does within an analyst over time or across analysts for the same firm at the same point in time, what explains disagreement/valuation changes? And we find that both these sort of more high dimensional attention vectors and variables, but also these valuation methods, they both sort of matter quantitatively for explaining these differences. And I'll again refer to the paper for details. What I want to get to and discuss in a little bit more detail is this idea of over and under reaction. So what I have on the left-hand side here is forecast errors, so realized returns or scale prices relative to expectations. And traditionally, what we would put on the right-hand side is forecast revisions. We can go, as I mentioned at the beginning, a lot deeper, basically. And rather than looking at forecast revisions, we can look at attention revisions. How much do you sort of, discuss a certain feature, a certain variable, and also in what direction using our sentiment measure. So we can basically relate forecast errors to feature revisions/excessive feature revisions if forecast errors can be predicted by these feature revisions, and as is sort of typical in that what is similar to sort of a Corbillon-Gorotnichenko regression, we would have a negative coefficient indicating overreaction here at the feature level and a positive coefficient indicating underreaction. And when we estimate this across the different topics, we see that there's quite a lot of evidence for overreaction to many topics, and those tend to be firm-specific topics such as product, customer, or pricing, and then there tends to be, on average, underreaction to macro topics like inflation or foreign exchange. As the last exercise, we can then go one step further and predict subsequent realized returns based on this based on these over and under reaction patterns, and we find evidence that there's a positive link between over and under reaction at the topic level and then subsequent realized returns in the directions that we would expect. And this holds true even after we control for your standard return predictors. So let me conclude. What do we want in this paper? We want to ask, how do people form expectations? What explains beliefs and where do they come from? 5 key findings using these analyst reports. Mental models predict forecasts, so attention and valuation methods matter, and they tend to be sparse and rigid. They're tightly interlinked, and we can use these new sort of newly measured sort of foundations of belief in that sense to understand disagreement over and under reaction, as well as return predictability. Thank you so much, everyone.
That was fantastic. Thank you very much, Marius. And also thank you, both of you, for really keeping your presentation within the 20 minutes. That's very much appreciated. So our final paper is from Manish from Georgia State University. The title is Generative AI, Managerial Expectations and Economic Activity. So now, again, we're going to move to another type of agent's expectation. Manish, as for Suproteem and Marius, you have 20 minutes. The floor is yours.
Okay. Oh, thank you so much for including our paper. Our paper is kind of similar to the last two papers, and I think that's the theme of this symposium. It's co-authored work with Jialin Baozong, who are both at Georgia State, and she's now at Rochester, and Michael Weber, who is at Purdue. In this paper, what we try to figure out is, could we use manager expectation to kind of predict something at the national level? So we know that CEO of these companies have some information. Could we use that to predict what's going on nationally? So we already know that managers kind of have a little bit of information. They are frequently talking to, let's say, presidents. So this is a photo from 2017 when President Trump had a board of economic advisors. And as you could see, these CEO of Pepsi, GM, they often talk to the government, and then they kind of often influence government. Um, so what we are trying to see is that, could we get into their head and kind of see what they are looking forward in the economy? And then would that be able to predict what would happen in the economy? So that is what our main goal of this paper is. Uh, so there are already surveys out there. So a simple way would be to basically, why don't you just use surveys instead of like actually trying to figure out some other ways? So there's a survey from Duke University, which has around 200 to 400 firm. There's another survey called SoFi, which is also have 200 to 400 firm, and that kind of gives you how these managers feel about different things. Uh, but one of the problem for these surveys is that they are kind of smaller in scale. The other problem they have is that the underlying data is private. And the last problem that they have is that it would be hard for anybody to kind of ask new questions. So in 2020, Duke CFO survey included ESG question. So you could see from 2020 onwards how people feel about ESG. But if you want to look back, you cannot do that. So these are some of the problems with these surveys. We are trying to see if we could kind of look at conference call to kind of figure some of these things without looking at the survey themselves. So this is what we do. We apply generative AI to conference call transcripts, and then we aggregate those information at the quarterly level. So basically what we do is we look at all the conference call from all the companies in a quarter. We ask ChatGPT how they feel about economy, and then we aggregate that answer at the quarterly level and then at the national level. And what we obtain at the end, we call that AI economy score. Our method covers basically all the conference call that we have access to. So it covers 5,500 firms. It sourced from everything is publicly available, and it's applicable to other dimensions of interest as well, as you would see. And it's also available at micro level. So some of the surveys that I talked about earlier, they are only available at the industry level, or sorry, at the national level. But if you want to look at, let's say, certain industry, or if you want to look at certain state or certain firms, that's where also our method kind of is better than surveys. So our final result is this AI economy score, and we say that it captures managerial expectations for the US economy in the next quarter. So our basically claim is that what AI economy score is predicting would be able to predict what would happen in the next quarter real GDP. We also try to see whether the predictive power persists in the longer term and for other economic activities like production, employment, and wages. So this is kind of our key figure. And I'll come back to this figure in like a future slide. So one of the major question that we are get asked often is that, like, isn't it very straightforward? Like, of course, you would see something in the conference call, and then that would be indicative of what's happened in the next quarter. So I just wanted to point out on one slide that it's not very straightforward. So a lot of time, these companies are have pressure to not reveal what they truly feel. So in 2025, Walmart CEO came out and they talk about tariff, but then they got a backlash. Similarly, Michelin, which we know as a restaurant grader, but it also makes tires, in their conference call, they were talking about how they want to have pricing discipline, but then they got kind of sued by antitrust EU that they are kind of colluding with other companies to kind of guide the price. So the point here is that these conference call might not be that obvious. They might be hiding their information, or they might not be just revealing anything about the economy, and they could just talk about their own firm. Uh, so I think a lot of audience would definitely think about is because ChatGPT kind of knows this period so well. So what you're predicting is just basically that look ahead bias. So we try our best to kind of exclude that. One of the advantage here that Suproteem has is that he has his own model, so he could kind of stop data at different points. We don't have that. So what we kind of do is, first of all, we look at survey forecast. So SPF, which is Survey of Professional Forecaster, also gives you information. So we look at whether this economic score is on top of survey forecast, and we do find that the economic score is on top of what survey forecaster gives us. We also do this something called masking the identity of the firm. So we basically remove, let's say, Apple, iPad, Tim Cook, or any of the information in the conference call that would reveal that it's a Apple conference call. And we do find that our results still persist. Um, we also kind of look at another thing that we didn't put in the slide yet is that we also use something by a new paper which is called entity neutering. We basically change the text in a way that an LLM could not kind of figure out which conference call it's talking about. So we ask LLM to kind of change the text but keep the meaning same, and then later on we ask LLM to figure it out. If they cannot figure it out, that's the only part of the score that we use, and then we see that even that score is predictive of what would happen in the next quarter GDP. We also use other large language model like Llama, and that also works. And then we are also trying to use smaller LLM models like Gemma, and this is something I'm still working on. If you have any more ideas, or if you have any concerns, do email me after, or if you have questions. As I was saying, the data source for our paper is very public. We use conference call transcript from Seeking Alpha and Financial Modeling Prep, but there are a lot of places you could get these information. Our real outcomes are from Federal Reserve, BEA, and CompuStat and CRISP, and we get SPF from their website. This is the prompt we used in the paper that we have it on SSRN. So what we used is basically we asked them that this is an earnings call, you're a finance expert. Uh, let us know how do you feel your optimism changes about the US economy. And then we gave them five choices. We tried with three choices and 0 to 10 as well, or 0 to 100 as well. But what we figured out when we look at manually, that five choices were one of the better results. So we stick with five choices. So this is our prompt. And then we also ask for an explanation. What we figured out is that when we ask for an explanation, the hallucination is much lower, and then they're actually picking up things from the conference call. So this is the prompt we have used in the paper. Currently, we are changing the prompt slightly. Uh, so this paper has been done with ChatGPT 3.5, but we are trying to kind of change that to 5 mini. And since the cost of 5 mini is lower, what we are trying to do is we are trying a different prompt, and instead of directly asking about economy, we were first gathering all the sentences that talks about economy, and then once we have all the sentences, in the second pass we are asking, based on these sentences, how do you feel about the economy? So we'll hopefully update that in a month. Like, it's on my head, but I have not done that. But that's the plan. um, as of now, what we had done is we chunked the conference call. So on an average, conference calls are around 7,000 to 10,000 word. We chunked that to 2,500 words. The reason we did that is because ChatGPT 3.5 has a window, but we are still working with 5 mini and we are still doing this 2,500 word chunk. The reason being that even the context window of 5 mini is maybe like 200,000 words. It doesn't work. So it would kind of ignore the text that is at the bottom of it. So we are still sticking with this word chunking. And then we just put everything in this scale, -1 to 1, decrease substantially to increase substantially. At the end of everything, we average these scores at the firm level, and then we average that scores at the national level and industry level. We get something called AI firm score at the firm level, AI industry score at the industry level, and AI economy score at the economy level. Once we have that, this is our summary stats. As you could see, AI economic score on average is negative. The reason for this is that I think our sample is has two recession that lasted for a while. So it's 2007 to 9, and then also COVID. So that would be one of the reasons. So if we exclude that, on an average, the people are more optimistic towards the next economy. These are our other summary stats. Our dependent variable, we take a log of the ratio of the economic indicator from, this quarter, T plus N to T minus N. As you would see, our paper is very much kind of closely follows this other paper that I'll talk next. So we are just using the Y variable the way they used it. Um, um, So we do a lot of validation tests. We have got so many questions. We just put everything on before the results so that people could focus on the result when it comes, instead of thinking did they validate on that or not. We did like a manual review, of course. Then we also did look at the topics, if they are talking about the topics that are kind of make sense for a negative outlook or positive outlook. We also look at the n-grams that are associated with each one of them and kind of see. We also did like a trend analysis, like look at how the actual GDP changed compared to what these people are predicting. And then we also compared ourselves with SPF forecast and how they are doing, and then how it changes across industry. So this one was our main figure of the table, a figure of the paper, which is basically, as you could see, blue line is our AI economic score, and the red line is our real GDP growth. As you could see, the blue line and red line goes almost together, except for maybe 2020, when the red line goes down first as opposed to the blue line. And we assume that it's kind of we take this in a good way, because if you just read the conference call in 2020 Q1, sorry, at the end of 2019 Q4, it would be almost impossible to figure out that the economy is going down. So we take this in a good way, is that the score is not looking ahead. It's just using the information that is in the conference call. Uh, we also look at industry level and how it changed. So this is another place where our score does a better job as opposed to other surveys which are at the national level. So as you could see in 28 to 2008, you have basically everybody was kind of not doing as well. But as you could see in 2020, everybody is like kind of pessimistic, but the healthcare sector was optimistic in 2020, and in 2021, technical services were like really optimistic. So this is also something that kind of we could, instead of looking at the national level sentiment or national level surveys, we could look at industry level surveys to kind of figure out which industries are doing better or worse. Uh, so this is our main result. So the whole idea of our paper is that could we predict realized GDP in the short run and in the long term at the national level, in the industry level, and the firm level. In today's presentation, I only put the national level result. I also look at other economic indicators such as industrial production, employment, and wages, and those are also in the paper. We also look at behavioral biases. So some people are normally more optimistic about the economy as opposed to other people, and we were like looking at how that would kind of affect um, the score. And then we also look at multidimensional information. So I'll talk about it as we go there. As I was saying, our paper kind of follows the empirical design very closely with the other paper, which is this paper ZZ, which is Zachris and Gilchrist paper. In their paper, they have this exact same empirical design, except for this AI economic score. What they are trying to say is that the GDP, which is Y here, is predictive from term spread, which is 10-year minus 3-month yield. So basically, if your 10-year yield is much, much higher, your GDP would do not as well, maybe. And sorry, it would do well. And then real Fed fund rate. And the GZ spread is basically how much is the spread between treasury rates and how much between treasury rates and privately owned corporate bond. So basically, how much is the extra yield you are paying if you have, let's say, Apple bond or Microsoft corporate bonds. So in their paper, they show that GC spread is predictive of a real economy, taking care of these two. We show that AI economic score kind of adds value to their paper. So this is our national level result. This is the GZ spread result. So when you have term spread, real FFR and ZZ spread, the R square is around 45%. When we add our result on top of that, the R square changes by 4%, which seems like not a lot, but to predict the next quarter GDP is super tough. So 4% is kind of meaningful. And then when we have both, we could see that our score is basically has a higher significance than the ZZ spread score here. Um, so the goal here is that predict realized GDP in the next quarter, and the magnitude is basically one standard deviation increase in AI economic score leads to 1.3% increase in the next quarter real GDP. We also look at long-term real GDP. So we basically would this quarter score would it be predictive of next 2 quarters, 3 quarters, 4 quarters, 5 quarters, and then we see that it persists till 4 quarters. So basically, if people are very optimistic in this particular conference call, that would kind of increase the real GDP at least 3 quarters going ahead. We also do VAR analysis. So we basically have 8 variables and we perturbed our AI economic score. And what we find is that one standard deviation increase in AI economic score, which is this figure, D, we find that the consumption increases by 2 points. We say that investment increases by 6 points, and output, which is the GDP, increases by 2 percent point above the trend. In the next figure, we also show financial and policy responses. So inflation increases. We also see that excess market fund doesn't change that much, but if you look closely, it's like a little bit ahead, like out of the zero in the beginning part. We also see that 10-year yield goes up and also federal funds rate goes up. So the whole idea is that the results that we are finding, if we perturb if people optimism about the economy, that would basically kind of have an effect on other aspects of the economy for 6 to 8 quarters. As I was saying at the beginning, we also have like we kind of diversify our results. I'm not sure how much time I have left, so I kind of missed that point. So let me quickly go in 5 minutes and then I should be done by 10:50.
I think 3 minutes.
Okay, so let me just do a super quick then in that case. So what we do is we basically look at 8 quarters behind and kind of figure out who is an optimist and who is a pessimist and who's a realist. So we look at if they predicted good about GDP and if the GDP did good. And based on that, like last 8 quarter, we identify each company as pessimist, realist, and optimist. Once we do that, it's obvious that pessimists would have a lower score, AI economic score, as opposed to optimists, which would have an higher score. But what we do find is that pessimists are like much lower when it comes to like a recession period. Um, and then when we try to predict that, we find that each one of them does a decent job, but none of them does as good of a job when they are all together. So AI economy score does the best R square as opposed to each one of them together. So that's kind of wisdom of the crowd. And the other thing that we kind of figure out is that if we kind of only look at the recession period, the companies that are pessimistic 8 quarters before the recession are able to kind of do a good job in terms of predicting the economy. So for us, the policy implication here is that if you want to predict economy, it might be better to focus more on the companies that are more pessimistic about the economy in general. We also look at which kind of company has better insight into the economy. So we divide companies into two groups. One of them would be very spread out. So something like Coca-Cola, which has business in almost all the states, as opposed to another company which is very state focused. And what we found is that the national level prediction is better for the company that are focused in some of the states instead of are having everywhere. So what we found is that companies that are more focused tend to predict the economy better. One of the reasons we think of is that basically companies that are more spread out might not have that ground level information, and other could be they must be more shy in discussing what they actually know. So they might be just using boilerplate information. Lastly, we also use a multi-dimensional approach. So instead of asking just one question about economy, we ask about everything, basically global economy, wages, employment. And when we create a weighted score, what we find is that this weighted score does a better job at predicting national economy than just asking about economy. And the reasoning we give here is basically a lot of time companies might not be willing to talk about national economy, but they might say it indirectly by saying that their input costs are increasing or they are looking at the employment cut down, something like that. So these are all the points of our paper. I'll just finish it in 30 seconds, which is basically we use conference call text and we use ChatGPT 3.5, but we are changing it to 5 mini now to predict national economy results. And then what we find is that AI economy score could predict what would happen in the real GDP. Thank you so much.
Thank you very much, Manish. That was fantastic. So I think, well, actually, thank you for the three of you. Now I would like to ask Tony if he could share his thoughts on these projects and maybe on the more broadly on this area of research. Um, I see that you already have some slides, so um, take it away, Tony. Well, I think we cannot hear you. You might be muted. Or
How about now?
perfect. Now we
Okay,
can.
great. Awesome. Well, thanks. Yeah, thanks for the invitation. This is an unusual position to be in, to see three interesting and actually quite different papers. They're all about economic forecasts and different, but they're very different agents and sort of very different sort of pockets of the economy. And so I think I want to start just by kind of talking about sort of two challenges that LLM papers or papers that use LLM uh, when we're sort of thinking about trying to capture reasoning. Sort of the most obvious challenges, and I think the ones that most of the presentations focused on, were aspects of internal validity. So one example of this is thinking about overcoming the LLM black box. And these papers have myriad checks on this dimension. If I were a discussant, I would kind of be able to pick through these things. But like honestly, my comments would be unfocused. This is if I focused here. I think kind of what's more interesting is to draw some of the interconnections between like what are the broader methodological lessons that can be gleaned, what are best practices, And sort of where does this kind of point? And so I think this is the theme that's kind of cleaner in this, even though they're all kind of about sort of different behavioral economics and reasoning. Really, the theme is kind of more technological in my view, and I think that's kind of what's interesting here. So just to kind of give you a sense, each paper deploys LLMs in distinct and I'd say innovative ways. AI and LLM measurement are new. Best practices really aren't settled. And each of these papers kind of has kind of candidate best practices that could sort of be pushed in different ways, right? So, Marius has a very interesting sort of way to kind of characterize different models that analysts use. And they sort of learn this from the way they structure their reports, right? And so I think what's kind of innovative here is just sort of how much they give to the LLM before it kind of tells them about the models. And then that sort of detailed reasoning is kind of outside of the LLM, and it sort of gives you kind of a nice, sort of a nice insight there. Manish, I think there's sort of a couple of different ways to view the paper. I think the way he explained it was he's using conference calls to train a finance expert and then ask the expert about expectations based on this. This is a cool structure where you could get kind of a synthetic macro survey of managers, and you might even just ask it. Suppose you're the manager yourself, and the markets mirror a paper I have with Chukwuma Dim, Vineet Begwat, and Marina Niesner. We do something similar to this, but less dynamic. I think there's a lot of potential to kind of treating the LLM as something to be surveyed, not just something that does sort of fancy text analysis, right? So, and then, I mean, not to be outdone, Suproteem has a very interesting sort of way to sort of learn representations from news. Way I think about this is it sort of gives us a way of how the market, or what he was calling the market, I would say the news media, thinks about firms, and sort of characterize how this matters for asset pricing. Really, it sort of gives you a sense of like how do shifts in the media narrative about what a firm is relate to valuations. I think he kind of gives like a sort of an interesting characterization of that. I think that one of the really impressive things technologically is he trains his own LLM, or actually family of LLMs, to prevent look ahead bias, and this sort of gives us, I think, sort of almost a gold standard in many ways. So. I think what do we need as a field, really thinking sort of about sort of the technical aspects of this, is that I think eventually we need to have some best practices, and these best practices are going to depend on sort of what our targets are, right? So, each of these papers has some potential for best practices. I think there's a version of this sort of AI economy score way where you sort of build it up like a survey methodology, and that could be a foundation for best practice going forward. There's also, if you look at Suproteem's work on sort of training sort of these more just-in-time LLMs, that's also got some best practice element, but there's sort of different contexts and different purposes, and I think we need to kind of figure out this mapping between when is the tool right for the purpose. Right. So I mean, something that's kind of missing from most of this, though, is that I think we also need to think about how this is going to evolve as we move to new generations of technologies. I think people are pushed to sort of do robustness, but actually thinking about how like the answers change as we get more or less sophisticated. I think Pietro, your work on behavioral economics of AI is a really good example of this. I think we need more work to think about those cross connections. These papers don't necessarily need that, but the field definitely does. There's another dimension here that was inherent in these papers. You could train your own LLM, avoid look-ahead bias, but that's a huge effort. And in some ways, it sort of limits how frontier the model can be. That sort of gives you a lot more control. But some of these off-the-shelf models allow you to do more sophisticated things, get it more nuanced, out of the box, powerful techniques. And so I think we're sort of at the edges right now. I think where the field kind of needs to go is to sort of think, well, can we find this middle ground? Is there some descriptive guidance about sort of different prompting strategies or different ways in the middle? Manish mentioned this entity neutering paper. I think that's one example of this, but I think we need a lot more work in the kind of the messy middle to sort of figure out when are we actually getting able to leverage the power while maybe not sort of subjecting ourselves to rampant bias. There's another core tension in using LLM measures is that these are most powerful when we can check them the least. When we want to actually sort of measure something and we don't have a measure for it, I mean, that's like the most valuable thing, but then we don't really have like a validation. So I think like, playing with that tension, I think is sort of helpful. I mean, we've wrestled with this in our own research. Do we trust a small sample of human responses? Is that the right benchmark? In some cases, we might look at other textual measures rather than the human benchmark. There's sort of a way to think about like these papers is like, I think this is sort of how is the LLM being used to elicit expectations? Is it being surveyed, or is it being really good at analyzing subtle dimensions and dynamic representations of the text? I think the papers kind of fall in sort of two different camps here, and I think it's sort of different directions that the field is going to be pushing. I think being clear about that this boundary tells us how much and for what we're relying on the LLM. And I think like we need kind of more clarity kind of along those dimensions as we move forward. And I think I'm excited to see kind of the direction that this research takes as we see new best practices emerge. So those are kind of my thoughts. They're one perspective. I'm sure there are many others. I wanted to leave just a little bit of time so that people could have a chance to raise their own questions. So thanks for the opportunity.
Thank you, Tony. That was fantastic. Actually, I think as a junior scholar, that was extremely useful to get a broader perspective on this field. Maybe yes, we can open the floor to questions. So if anyone has questions, please feel free to put them in the chat, or feel free to unmute yourself and jump in.
Hi, can you hear me?
Yes, we can.
So my quick question is for Manish. I was wondering, so the context you give the LLM for generating these expectations, to what extent does it actually matter compared to just asking the LLM, you're the manager of this company? Like, what you're getting, is it the perspective of the manager or some distillation of the context that the LLM has from the conference call?
So I'm actually working on another paper that does exactly that. And it's able to predict well, provided you let it search the web. So in general, if you just ask ChatGPT about, let's say, Apple, if you do an API search without a web search, it would not do a good job. But if you let it search the web and like figure out the transcript and whatever the Apple CEO said at the time, it would be able to do a good job. So in that case, you don't have to do the conference call if you let it search the web and figure out other information.
I see. So, but currently what you have is the case where it doesn't have access to the web. This is just
Yes.
the
So
NS
currently
conference
I'm
call.
just giving them conference call, text, and yes, no access to the web.
Okay. So I guess why I ask is because even if in the case you do this entity neutering or you kind of mask who the manager is, I think in some sense the model, knows at this point in time this is who the manager is and kind of was involved in this
So
conference
the
call.
way we did entity neutering is basically after we entity neutered, we asked them to figure out which company it is, and we only used the data if they couldn't figure out the company. So if they could figure out the company, we don't use that information.
Maybe we have time for one or two more questions. I think Leah is unmuted. Yes, go ahead.
My question is for Marius, right? I was wondering whether when you try to assess analysts' mental models, whether there was any way to try to account, or whether you do, or if there's any way to try to account for analysts' conflicts of interest, right? As part of how they describe the firm and what they pay attention to, kind of the different, you said it's very sticky, kind of the different and they're very restricted, kind of the list of components that that make up their mental model. So I was wondering if there's any role for studying their conflicts of interest.
Yeah, no, I think that's a really cool question, and like obviously there's a huge literature on analyst incentives. So the way we think about this is ultimately we know that their quantitative beliefs predict prices. And the quantitative beliefs are in some sense affected or influenced by, the incentives and their conflicts of interest, as you put it as well. And so like within that sometimes possibly messy context, we just want to understand these beliefs as well. And like partially what these discussions might reflect is also their incentives, right? So like what coming from the perspective, okay, the beliefs matter for prices, then let's say, okay, let's go one step further than that. But I'm fully with you that partially, or at least partly, that'll reflect what you're saying. Yeah.
Thank you.
I think I have one last question, and then I think we need to wrap up. My question is actually for a Suproteem about his economic representation. I was curious about, do you think you're measuring exactly how firms are represented, or also how salient narratives are, in the news about these firms? How to disentangle those?
Yeah, yeah. I mean, I think the challenge here to map the empirical object to the conceptual object is what I care more about in the model is how the representative investor, you might say, is characterizing the firm or thinking about the firm. But as far as the data, I can't scan their brains. I have to do something downstream and look at kind of the characterizations of these firms in the media. And there's reasons to believe that this could be aligned, right? For example, if the you know, funds are paying the news to, report on certain parts of firms, right? You might think that the coverage of the news mirrors what the funds want to know. But of course, there are other things that may move the characterization in the media astray from how the market, thinks about the firms. For example, there's some liquidity-based price movement. The news kind of jumps on and says, "Oh, this is a change in what the firm is doing," when in fact the market is not moving the price because it's changing what it thinks the firm is doing. And there's more in the paper trying to disentangle, some of these effects, trying to see whether there's evidence that supports the sort of concept empirical map versus not. I think it's a great avenue for further research, right? Finding ways that we can align this language data to better kind of correspond to whatever theoretical object we're interested in proxying for. There's work on representational alignment that's informing some of my future research. That's one strategy. You can think a little bit more about attribution and kind of data selection. But I just want to say that it's a great question. I think about it a little bit in this paper, but there's definitely a lot more to do, both conceptually and technically for it.
Thank you very much. I think we're running out of time, so I think I need to we need to wrap up here. But if other people have questions, please feel free to email the speakers directly or our distinguished panelists, or feel free to send them to me, and then I'll forward them to all of them. I wanted to thank everyone again for joining us. Thank the speakers and our distinguished panelists for joining us today. Our next event is going to be on April 30th. We're going to have Hui Chen from MIT. Our host is going to be Svetlana Brizgalova, and we look forward to meeting everyone there. Thank you again for joining us. Have a great week.